This is a video lesson on solving trig equations. We'll look at several examples, starting with a basic equation like sine of x equals negative 0.1234. In working a problem like this, there's going to be some need for approximations, and you should be instructed on problems whether you're going to work in degrees and radians and how accurate those solutions should be given. So on this example, let's work with degrees, and let's say we want to round our solutions to the nearest tenth of a degree, and we want to find all solutions. Since the sine function is periodic, we know that there are infinitely many solutions. To start, we need to look at the inverse sine function of negative 0.1234, and using a calculator to the nearest tenth, this is negative 7.1 degrees. Okay, of course you'll want to check your mode to make sure you're in degree mode. Well, that's only part of the information that we need. If we draw a picture here, negative 7.1 is down here. It's a bit exaggerated, but it's approximately there. And we could use that angle as is, or we could use the positive angle, which would be 352.9 degrees. Okay, so what we're going to end up with then, x is approximately 352.9. Or if you wanted to, you could write negative 7.1. That's okay. There's actually infinitely many numbers we could write there. And we can cover all of those possibilities by putting in an expression like this, 360 degrees times n. And in this first instance, I'll write down what n is, but you don't have to always write that. It'll be understood that n is an integer, so that it would be 0, plus or minus 1, plus or minus 2, and so forth. Now we're not done, we're actually halfway done. We know from our knowledge of trigonometric functions that the sine function will hit a value of negative 0.1234 in two places in the unit circle. We found one. The other place where we're going to find a negative 0.1234 for the value of sine would be a reflection of that angle about the y-axis, so this angle over here. And that angle from here to there would be 180 degrees plus 7.1, so 187.1. So to complete our solution, we'd need to put in the other half, which would be, or x is approximately 187.1 plus 360n. Okay, so the full solution set is x is equal to 0.9 degrees plus 360 degrees times n, or x is 187.1 degrees plus 360 degrees times n. Here's a similar problem, but a little different. Let's say I had sine of 3x equals 0.1234, and I want to find all solutions. So as before, we're going to want to take a look at the inverse sine of 0.1234. And we would know this to be approximately 7.1 degrees. So following a similar process, except this time we're going to have 3x is approximately 7.1 degrees, or 3x would be approximately equal to the angle in quadrant 2 in this case. So here we've got our first angle 7.1, but our sine function will also have that same value in quadrant 2, and using some symmetry here we would take 180 minus the 7.1 and get what would that be, 172.9. Alright, so there's two solutions, the two solutions for this initial equation in quadrants 1 and 2. But when we're looking for all solutions, we'll need to complement that with adding in the 360 degrees in. You have to be a little careful in the order of operations. We're almost done. The last step would be to divide through by 3. And when we do that, we'll end up with rounding, we'll end up with x is approximately, taking 7.1 dividing by 3, you get 2.36667, so about 2.4 degrees. A common error is to omit the division by 3 on this part of the expression on the right, but we don't want to forget that. We're dividing everything by 3, so we should have 120 degrees in for that guy. And similar for the other half, we'd have x is approximately equal to 57.6 degrees. So the full solution set is given in the yellow box there. So notice that the process is very similar whether you have a multiple angle equation versus just a single angle equation like the first example. For our third and last example, let's look at a multiple angle equation, but this time we're only interested in finding approximate solutions within 0 to 360 degrees. Well, we would start this problem exactly as before. It's the same equation as we had earlier, so we know using the previous steps that x is approximately 2.4 degrees plus 120 degree n, or x is approximately 57.6 degrees plus 120 degrees times n. So start off these kinds of problems exactly as before, and now we'll just pick off the number of solutions that are between 0 and 360 degrees. So in this case on the left, when n is 0, we get 2.4 degrees. And when n is equal to 1, we would add 120 to that and get 122.4 degrees. So that's n equals 0, n equals 1. And then we have one more. If I add another 120, we would have 242.2 degrees. 0.4 degrees. So there's your n equals 2. If we add another 120, we're going to be beyond 360, and therefore for this left equation there are 3 solutions. And we'll also get 3 solutions for this equation on the right. We would have 57.6 degrees, for n equals 0. For n equals 1, we would times 120 by 1, add that to 57 and get 177.6. And finally, for our 6th and last solution, we would add another 120 to get 297.6. I ran out of space there. So giving us a total of 6 solutions. And had this been sine 4x equals, or sine 5x and so on, you would end up with twice this number. So here we had 6 solutions. If it was sine 4x equals 0.1234, we would have 2 times 4, or approximately, or 8 solutions, 8 approximate solutions. So there's a process for solving equations, both the single angle and multiple angle. Had we worked in radians, we would just choose radian mode. And with radians, I tend to go out a bit more in accuracy. So instead of 1/10 of a degree or 1/10 of a radian, we probably want to round to about 4 decimal places on the radians. Hope this helps. Thanks for watching.